need to try to keep it up here. All right. So, oh, see, that's not going to work. Yeah. Okay. So that's the x values. The range is going to be the set of all y values, or the output. That's the dependent variable. So the dependent variable is depending on you determining what the x is, to plug in solving for y. Okay, so the domain is what you put in. The range is what you get out. So now we'll talk, that's a relation. So there's a special type of relation called a function. Okay, so personally I think if we plug in an x value and we get 2 y values out, that kind of makes us scratch our head. Like we kind of expect to only get 1 y value out. So that is defined as a function. So you plug in 1x, you only get 1 y out, right? So instead of having 2 dependent variables, you just have 1, right? All right, so that is a function is a relation where every element in the domain, or every x value, corresponds to exactly 1 element in the range, which the range is what? The y values. All right, so if we look at these examples here and we ask ourselves, for A, do we only get one value out? We plug in A, we get 2. We only get 1 number out. So far so good, it is a function. For C, we get the number 3. So that is a function. So this is yes. For every x, we only get 1 y. Okay, so if these were all the x values and those are all the y values. Okay, so now here, for every x, do we only get 1 y? Yeah. So this one's a yes. Okay, so for A, we get 2. For B, we get 2. And for C, we get 3. So the y is doubled up, right? But that's not what we said. We said for 1x, you get exactly 1 y value out. Okay? We don't care if it happens a million times. You get 1 y value for every x that you plug in. Okay? All right. So how about this one? Well, what do you think it is here? No, because of C. So here this is a no because for 1 value, which is C, we get 2 values out, and namely 2 and 3. So we get a 2, so I plug in C, and I'm going to get a 2 and a 3. Like I said, that kind of makes you scratch your head. It's like, uh-oh, Houston, we have a problem. Right? We've got 2 numbers coming out. All right. Okay. So how about down here? Does the table represent y as a function of x? So in other words, we're just kind of introducing a way that we describe this thing that we're doing, this new thing we're doing. Okay, so for every value of x here, do I only get 1 value of y? Yes, because this -2 will give me -3, 1 will give me 2, 3 will give me 4, and 8 will give me 9. So, yes. So it's the same thing. Every x gives only one y. Okay, so how about this next one? -4, I get 3. What do I get when I plug in 1? I get a 3, and I also get an 11. So they didn't order it, so they didn't make it easy on you, right? But you see that I could plug in a 1 and I get a 3, and down below I plug in a 1 and I get an 11. So do you think this is a function? No. So this is no, not a function, because for input x equals 1, we get output y equals 3 and 11. Okay, so pulling that concept of it being a relation and a set of ordered pairs back in, we have a 1 here, this is a 1, 3, and this is a 1, 11. Okay, so a function is a special type of relation. You can see that we have a bunch of ordered pairs, everything's paired up. You have an input and an output. Okay? Are there any questions? Good so far? Okay, so I'm going to give you, get it? I'm going to give you another trick. So if you just looked at a graph, how would you be able to tell if it's a function or not? Right. Okay, so what we can do is like right here. So this line right here, so the curve, this is really like this is really the line that we're looking at. Okay, so I hate that they kind of drew that line in there because I would have rather done it myself. But this is, say this green highlight is the only thing you were given. And I wanted to teach you about this way to just look at it visually. I tell you to draw a line at x equals 2. So in other words, it would be much better if I could just take my ruler and put it at x equals 2, right? If they hadn't drawn that line, I would have taught it this way. All right, so if I draw that line there, does that line hit in more than one spot? Yes, it hits right here, and it hits right here. That's called the vertical line test. So you can kind of just look and think about it and say, you know what, it hits in 2 spots, so therefore it is not a function. Okay, so it's not a function. Now, if, let's say for example, if I'm thinking about that set of ordered pairs, right here I would have 2, let's say it's 2, 6, right? And then I would also have 2, let's say 2, 2, 2. So for that one value of x, I'm getting 2 values of y. Negative. Negative 2. Yeah, so it's a negative. I apologize. I don't know what I'm thinking. Negative 2, thank you. So for that value of x is negative 2, I would get those 2 values in my ordered pairs. I'm approximating just for sake of discussion, so that you can see the connection between the fact that that vertical line test is doing the same thing that we did on the last page. Okay? All right. So how about this one? If I take my ruler and I go along here, anywhere on here, is it going to hit? Again, this is, like I said before, this is the function that we're evaluating. Okay, not that line there. We're just demonstrating the vertical line test. So if I take that ruler and I go along here, does it ever hit in more than one spot? Okay, so yes, this is a function. I'm just going to put fxn, that's how I abbreviate function. All right, because it only hits in one spot, right here. Okay, and the next one, what about the next one? No, I mean, it does give you the answer right there, not a function, right? Because I take this line and I draw it, and it hits here, and it hits here. Okay, notice that like right here on the very tip, on the tips of this circle, it's only going to hit in one spot. So you have to look at all values of x to determine if it's a function or not. This one's not a function. This one's clearly not. Look, it hits in 3 places. Okay, so this is not a function. Okay. Right. So for one value of x, you get 3 values of y. Okay, so now we're gonna focus on domain and range. What value is the domain? Do you remember? The x value. So x values, and the range is the y values. All right. So now, when we do set notation, if a number is repeated, we just write it once. Okay. So the x values are -2, -2, -2, -2. So we only write one of the -2's there. It's repeated. All right. So my range is my y values. So what are my y values? I have 6, 5, 4, and 3. Okay? And it is prettier if you order it, but you don't have to. Okay, you can just write them down. So is that relation a function? Okay, so what do I get if I plug in -2 then? Do I only get one y? You get multiple. So now let me ask you again, is it a function? No. So so the question is, does every x that you plug in output only one y? No. The answer is no. So therefore it's not a function. So no, because -2 outputs six, 5, 4, and 3. That's 4 numbers. Okay, not 1, but 4. Okay, so it's not a function. Is that clear? Okay, good. All right, so now we're going to do the same thing here. So we get domain is the x values, right? So we get -7, -6, -5, and -4. What's the range? 5, 4, 3, 2. Okay, so let's start at the beginning. So if I plug in a 7, do I get only one y out? Yes, I get 5. If I plug in a -6, do I only get one y? Yes, I get 4. And -5, I only get 1 is 3. -4, I only get one y is 2. So yes, this relation is a function. I'm just so this is actually called a one-to-one mapping because it goes both ways. But anyway, because every x has only one y. I'm kind of describing it in different ways in case like it makes a difference for you for me to say it a different way. Okay? Do you understand? Okay. Okay. So I had a thought about this on the drive-in today. You know those wooden snakes you can buy like at the zoo or whatever the store, and they curve, they're curvy, and what if this graph was one of those snakes, okay? And I took that snake and I collapsed it so that it was straight. Okay, so I'm gonna take this snake and I'm gonna collapse it. Well, it would probably extend out, but I don't want it to extend out, right? I want it to stay right in there, but I just want to shrink all of these values on this line here. I want to shrink them all down to the x value so that we're back to our good old-fashioned number line. So in other words, remove that other dimension, the y dimension. Okay? So that is your domain. Those are your x values because this, like we said before, this is the x-axis, right? So we're taking that and we're collapsing it. All right, so the way I'm going to do that, so I can show you, is the domain is going to start the very first, if I come from the left, okay, start from the left, and you look to see what is that first x value that you hit. -3, okay? You hit x equals -3 first, right? All right, then we keep going, and we want to see, once that thing's collapsed onto the x-axis, what is the final value of x? We don't stop here, right? We don't stop here. We keep going because that collapsed thing will still keep going. So we come all the way over to here until we hit 2. Okay? So, and then you hit 2, x equals 2 last. -3 to 2. -3 to 2. What did you ask me? -2? -2 is right here. Yeah, but when we collapse it, that's not going to be the last number we hit. So I'm asking you, if you come from left to right, what is the very last number you hit? It is going to include, the domain is going to include -2, but it's going to keep going. That collapsed snake is going to be, actually, let me do it like this. It's going to be from here to here, right? So I'm trying to show all those numbers from -3 to 2. Now, okay, guess what? There's an open circle here, so you don't actually hit it, you just circle through. Right? So I probably shouldn't have said x equals 2. But I'm not sure how else to do that. I guess I could say you almost hit. Almost hit. Because you guys know how I think now. So unfortunately, I feel bad for you. All right, so you're almost hitting 2, right? So you're going from -3 to 2. So on this number line where we collapsed it, we go from -3 to 2. And there's a closed circle on -3 and an open circle on 2. So then, isn't this going to be a square bracket, and that's going to be parentheses? So the domain, which is down here, we're going to have a square bracket, -3, up to 2, and we're going to exclude 2. Okay, so always think of that x as collapsing, because almost always the domain is the one that people get wrong. So if you think of it collapsing into that number line, okay, because people, like a lot of times people will stop here, because they see that that's the highest point, but that's the range. The range, for the range we're going to go, sometimes it's easier if I use a paper. So for the range, I'm going to come from the bottom. So we're going to go from the bottom to top. So we start here at the bottom. And the first spot, I'm looking at where this is hitting my paper, right? The first spot that hits is down here at what y value? -5. Yeah, the y value is -5, right? So I'm all the way down here at the bottom, it's -5. Okay, so it's going to go from -5, and I'm going to go up, up, up. Where is the very highest tippy top point? 4, y equals 4. So it's going to go all the way up to 4. Yeah, sure, no problem. All right, so so if you have that, then I ask you, is this going to be a closed circle at -5? Is it going to be included, a square bracket or parentheses? It's square, right? Because it's included. Now 4, well, all these dots, there's infinitely many of them, right? They're all filled in except this last one. So is this dot up here filled in? They're all filled in. You see how it's solid? They're all filled in all the way up to 2. This one's open. Do you see that? Because when I graph this, I graph all the way I graph all the points is I just don't pick up my pencil until I get down, or a pen, until I get down there to 2. And then I pick it up right at 2 because it's not included. All right? Does that make sense? So this is a closed dot here. So this is going to be a square bracket. So even though the domain has a parentheses, it doesn't necessarily mean the range does. Because that point right there of the tippy top is included as part of the graph. Okay, how did I do? What did you think of the snake thing? Okay. Well, sometimes it reaches some people and not others, so go with it. All right. So, is it a relation? Is it? I mean, it is a relation. Is it a function? Yes. Yes. Why? Vertical line test, right? You can do the vertical line test. You can see it only hits in one spot. Okay? So it passes. I'm just going to put VLT, and that means vertical line test. And you can do that too, like on a test. If you're showing your work, you can put VLT. Yeah. Yes. Yes, that's right. But we're not there yet. All right. Okay, so now, I'm thinking I should have you guys try this one, and I'll come around and check. Just make sure you're getting the hang of it. But there is one thing I want to point out. They don't have arrows, which, that's kind of like my pet peeve. So if you have arrows, it means it goes on forever, right? And it's going to be going up like this, right? So be careful with that domain. Think about that it keeps going and going and going. Okay? So if you take that snake, what's going to happen to that snake? I mean, it would have to be an infinitely long snake, right? So imagine that it's infinitely long, and where would it end up on that x-axis? Okay, go ahead, try it now. Raise your hand when you think you have the answer. Anything else you guys done? Yes. Well, she is. Okay, good. Yeah, that one. Okay, so I think you guys are getting the hang of it. A couple of things. So let me ask you this. Is there any value of x that I'm not allowed to plug in? No, I can plug in any value of x, right? What about in this graph? What value am I not going to plug in? -4, right? -4 is not pictured on the graph. So up here, you cannot, I just put you can't plug in -4, for example. Right? So my domain does not include -4. Did I depict that in my answer here? You see? Because I'm only going from -3 to 2. So the question is there any value of x that you can't plug in? No. All right, is there any, let me word it just one more way to drive it home. Is there any value of x that's not being used? There's no value of x that's not being used. Every value of x is used in this graph, right? So I could put in anything for x, and it would be on the graph. It might be like a billion, right? But it will be there. It goes on forever. Okay, this one's hard because for the x values, it grows so gradually. It's hard to conceptualize that it's still growing, and plus they didn't put any arrows on it. So the domain is -infinity to infinity. And what's the range? -3 to infinity. And remember, I have to put a parentheses on the infinity. All right, so when we do range, you just take your paper, you start at the bottom. This is, you go bottom to top. So you start at the bottom. The first number, the first y value, we're focusing on the y values now. The first y value you hit is -3. Okay? The last y value you hit is going to be infinity. You just keep going and going and going. Okay, so that's why. Is it a function? Yes. So most of you said you're doing the vertical line test, which is perfect. You just look and you see you only hit one spot on the graph as you go from left to right. Okay, so yes. Okay, very good. Pen check. Okay. Okay, so now we're going to find the domain and range of this function graph below. Write our answers in interval notation. All right, so the domain is going to be, let me check because I'm pretty sure they intended that there's an arrow on the end. It goes on forever. Okay, so please update your notes to put that arrow on there. Okay. So we're going from, so let me ask it this way. What values of x are they using in this graph? Right, 2 is included. Yes, to the negative, all that goes on all the way to negative infinity, right? So they're using in this graph. So that might be another good way to think about it. What values of x are they using? Well, they're using negative infinity all the way up to and including 2. Okay, so if we collapse it, like the snake, then it's just going to be on the number line. it's just going to be 2 with a closed dot all the way to the left. So the domain is negative infinity to 2. So the range, we're going to go bottom to top. So we're going to take our paper and start at the bottom, and we're going to ask ourselves, what is the first number that we hit? We hit an arrow, right? So what does that mean to you if you hit an arrow? Negative infinity. So you're going to go from negative infinity, that's the bottom. And what is the last y value? 0. So the last y value you hit is 0. Square bracket, because it's a closed dot. Okay, good question. All right. So, let's do this one together too. Find the domain and range of the function graph below. All right, so the domain is, so this is a good one that we can shrink down, right, onto our number line. So what is going to be if we flatten it? We just take that circle and we just flatten it, right? What's the first value on our number line going to be? -5. All right, so we have -5, and what's our last value? 1. Good. All right, now is that a closed circle or an open circle? Closed. And so some of you might say, well, the whole graph is an open circle, so but no, it's a closed. So these are both closed, and then I should use a different color. The color won't be able to see red. It's in between there. So the domain is -5 to 1, and I use square brackets because, oops, because -5 and 1 are included. All right. So the range, go bottom to top. Bottom. So I take my paper, I'm going. I still haven't hit the graph, right? I keep going until I actually hit the graph, which is right here at what y value? -3. You've got to pay attention to the y value, okay? So we're going from -3, and it's open or closed right there. It's filled in, right? So it's going to be a square bracket. Okay, and what's my tippy top? 3, +3. So we go up to 3, and it's a square bracket. All right. Is it a function? No. Okay, because you can see there's all kinds of spots where you get 2 points, right? You do the vertical line test, and it fails. Fails VLT. Vertical line test. VLT. It's Krista, right? Yes. Hi. So I'm gonna write this here for you because I think you came in after I said that. So the vertical, this VLT stands for vertical line test. Oh, we didn't talk about that one. Yeah, thank you. So what will you tell me then? Is it a function? Yes, that's right. Yes. Okay, so if I take my paper and I move it vertically like this, I only see my paper hitting 1 point at a time. So I'm good to go. So this one passes the VLT. Check. All right, so let's just do this one last page. Okay, so we're going to find the domain and range here. Okay, so we have an open circle here, and we have an open circle here. All right, so I think I'm going to have you guys try these last two, and then raise your hand after you're done with each of them so I can check and make sure you're on track.
Oh, you did? Yeah. Yeah. So think about it like collapsing. Yeah. Think about it collapsing this way. So we're not going to distinguish the one that we collapse it. We're not going to distinguish that one with it's all just going to go. Where's yours? With the domains. So domains going back.
He actually left. He drove away. I'm riding live. Are you riding live? You get it out. You get it out. You get it out. Jail. Oh,
Oh my god, you're the one that created the situation.
Can you remember 2-0?
All right, so let's do it together. That helped me. That helped a lot. So let's do it together real quick. Okay, so I want to point something out. When you're looking at this graph right here, let's list some of the ordered pairs. Okay, so we have that x, y, t bar, right? So if I plug in -3, what am I going to get out? So this point, in other words, what is that point right there? What's the ordered pair? It's -3, what? 0. The y value is 0. So that's -3, 0. Now, what about -2? This point right here, what's that point? -2, -2, 2. Oh, that's why I said 2. So it's -2, 2. Okay? Now what's this point here, up here? Is -1, 4. Okay? 0, 2, right? You see the ordered pairs? I'm forming the graph. And I have 1, 0, 2, -2, 3, -4, right? And then 4, we have an open circle, but we still have it. 4 is 1. Open. All right, so tell me, these are all the numbers. All these numbers have to be included in the domain, right? You see that? All these numbers, we're going to have to describe a way to include all these numbers for the x values, because the domain is talking about the x values. The range is talking about the y, so we'll have to find a way when we do range to describe these. Now what about 1.5? What about 1 and 4? All the numbers in between these are also going to be in that domain. Okay? So the way we describe the domain then is we're going from -4 to 4. Okay, so we don't want to include 4, but we want to include all the numbers right up to, but not including 4. So we use parentheses to do that. Does that help anybody to see it that way? Okay, so when you're not sure, start listing some x values. Actually just list some ordered pairs. Start labeling your dots. Make sure that at the minimum you're including the stuff that you labeled. Okay? All right, so let's look at our y values. We have a 0, a 2, a 4, a 2, a 0, a -2, a -4, a 1. So what's the highest number I listed there? 4. And the lowest number? -4. So worst case scenario, you could do that. And then at least you get partial credit, right? Like that's the highest number I got and the lowest number I got. Now, those 2 points are right here. 3, -4, and up here, -1, 4, right? Do those have open circles on them or closed? Closed. So we're going to use a square bracket. Okay, what time is it? Okay, I've got 3 minutes. All right, so that's how we do domain and range. Okay, so I think that in my head. So I'm not describing everything that goes on in my head, right? But that's how I think about it. Those are all my x values and all my y's. Does that help? Yeah? Okay. All right, so great. So the relation is a function because if I draw a vertical line anywhere, all of these numbers just gave me one output. I put in all these x's and I only got one y. And you can kind of see a trend that you're always going to only get one y out. So yes, it's a function. And also it passes the vertical line test. So you could tell me either of those. All right, so what is the smallest x value? Okay, keep the chatter down because some people are still learning here. Okay, so what is the smallest x value that I'll plug in here? 2. So this would be the smallest x value right here, 2. So 2, and is it an open circle or closed? Closed. So right here, this point is 2, -1, 2, -1. Okay, so that's my x, y. All right, and then the biggest one is, well, again, if I put the arrows on this, so it goes on forever. So I can plug in any number greater than 2. And it will be on the graph. So that's infinity, right? Okay? All right. All right, so then the range, this is going to go on forever. So if I think about collapsing this onto the y-axis, just like we did with the x-axis, I'm going to take this snake, right, and I'm going to collapse it right here. And isn't it going to go on forever and ever in both directions? So that's going to be -infinity to infinity. Remember, we use parentheses on infinity. Always use parentheses. Is it a function? No. Good. All right, no, because if I do that vertical line test, like right here, you see that line right there hits in 2 spots. So no, it fails the vertical line test. Okay, thank you all for being patient.
Oh, yeah, we're doing the quickly.
Not today.
Oh.
Oh, thanks. I got everybody when you came in. Although the door wasn't.
Oh, no, I was going to grab
The door wasn't unlocked. Yeah. Yeah, so I guess you save me probably on every day. Does the janitor call you?
Every time I see them in the hall, but I never see them in here, so this might be a room they go first. And then they went over when we met.
Yeah, so I think you would keep her for him. Because he was like, I unlocked it. I called security. He's like, I unlocked it.
I wasn't here, so I wasn't.
Yeah.
Yeah, they,
You know, if you step back, you don't have to.
no, I'm always in here. I usually see them with the car jumping in the trash.
Have a great rest of your day.
All right, you too. Have a good day. Thank you too.
Have a good weekend.
Have a good weekend. Woo-hoo. Think about that too. Okay, bye. All right, you too. You can have stuff delivered.
I have to buy it for the bookstore. It's an old number. I have to buy it for
Okay. Yeah. I don't know. I'm not a student, but I'm pretty sure you can probably let it down there.
I was like speeding on the courthouse. I was flying.
I put this on the calculator and I don't what to do next. So I don't actually get to it. When I put on my calculator, it was like 2.33 times the percent.
Oh. So the E means it's times 10 to that power.
last two questions are kind of, related.
So it's gonna be 8.7 times 10 to the negative
8.7 times 10 to negative 32.
Yeah.
That's what that means.
32. Yes.
That would have been really.
Well, I will teach you.
The only reason I know is because Mr. King.
Yeah.
I'm doing it now because my Chromebooks from the this is from the high school, and I have really, really bad service. So whenever I move from point A to point B,
Oh.
sometimes my work does not save.
Oh, okay. So, why don't you hang out here?